Welcome all to my presentation. My name is Murtada Muhammad Abdul Ghada. Today I will make short presentation about natural gas. Starting with the agenda of presentation, first we will talk about the history of natural gas. After that we talk about the origin and the composition of natural gas, also gas sources and natural gas phase behavior and properties. Start with the introduction and natural gas history. Natural gas is an emergent fuel of choice for environmentally aware due to the lower noxious emission compared with other fossil fuel. Natural gas is used primarily as a fuel and as a raw material in manufacturing. It is used in home, fuels, water heater, and cooking stoves. As an industrial fuel, it is used in brick, cement, and ceramic tile kilns, in glass making for generating steam in water boiler, and as a clean heat source for sterilizing instrument and processing food. As a raw material in petrochemical manufacturing, natural gas is used in produce hydrogen, silver, carbon black, and ammonia. The ammonia is used in a range of fertilizers and as a secondary feedstock for manufacturing other chemicals, including nitric acid and urea. Ethylene, an important petrochemical, is also produced from natural gas. Natural gas is considered as an environmentally friendly, clean fuel, offering important environmentally benefit when comparing to other fossil fuel. The superior environmental qualities over coal or crude oil are that emission of sulfur dioxide are negligible, or that the level of nitrous oxide and carbon dioxide emission are lower. This helps to reduce problems of acid rain, ozone layer, or green gases. Natural gas is also a very safe source of energy when transported, stored and used. This was a short introduction about natural gas. Now we will talk about the history of natural gas industry. The discovery of natural gas happened in the ancient time in the Middle East. Thousands of years ago, it was noticed that the natural gas species originated by lighting, creating burning spring. In Persia, Greek, or India, the people built temples around these eternal flames for their religious practice. However, the energy of value of natural gas was not recognized until approximately 900 BC in China, and the Chinese drilled the first known natural gas well in 211 BC. In Europe, natural gas was unknown until it discovered in Great Britain in 1659, although it was not commercialized until about 1790. Historically, natural gas was discovered as a consequence of prospecting for crude oil. Natural gas was often unwelcoming byproduct, as natural gas reservoirs were tapped in the drilling process, and the workers were forced to stop drilling to let the gas vent freely into the air. Now, and particularly after the crude oil shortage of in the 17th, natural gas has become an important source of energy in the world. Throughout the 19th century, natural gas was used almost exclusively as a source of light, and it is used remained localized because of the lack of a transport structure, making it difficult to transport large quantities of natural gas long distance. There was an important change in 1890 with the invention of Lake Proof pipeline, coupling, but the transportation of natural gas to long-distance customers did not become practical until the 1920 as a result of technology advance in pipeline. Moreover, it was only after World War II that the use of natural gas grew rapidly because of the development of pipeline network and storage system. Now we will talk about the natural gas origin and composition. Natural gas exists in nature under pressure in rock reservoir in the earth crust, either in conjunction with and dissolved in heavier hydrocarbon and water, or by itself. It is produced from reservoir similarly to or in conjunction with the crude oil. Natural gas has been formed by degradation of organic matter accumulated in the past million of years. 2 million mechanisms are responsible for the degradation. And also it is divided into biogenic and thermogenic. Biogenic gas is formed at a shallow depth and low temperature by anaerobic bacterial decomposition of sedimentary organic matter. In contrast, thermogenic gas is formed at deeper depths by thermal cracking of sedimentary organic matter into hydrocarbon, liquid and gas, and thermal cracking of oil at higher temperature into gases. Biogenic gas consists almost entirely of methane. In contrast, thermogenic gas can also contain significant concentration of ethane, propane, butane, and heavier hydrocarbonic. The principal constituted of natural gas is methane. Other constituted are paraffin hydrocarbon such as ethane, propane, and butane. Many gases contain nitrogen as well as carbon dioxide and hydrogen sulfide. Also, we can see now here in this table the percentage of these gases. For example, we have the methane, ethane, propane, butane, pentane. For example, we can see the volume in natural gas. For example, methane about 85. The percentage of the methane is lower, and the propane also is much lower, and the other gases is very low percentage. And also the natural gas considered dry when it is almost pure methane, having had almost of other commonly associated hydrocarbon removed. When other hydrocarbons are presented, the natural gas is wet. The composition of the natural gas varies depending on the field formation or reservoir from which it is extracted. And now we will talk about the gas sources. Natural gas produced from geological formation come in a wide array of composition. The vertige of the gases composition can be broadly containerized into three groups: non-associated gas that occur in a conventional gas field, associated gas that occur in conventional oil field, and continuous or unconventional gases. For non-associated gases, sometimes called gas or gas, is produced from geological formation that typically do not contain much, if any, higher boiling hydrocarbons, gas liquid, than methane. Non-associated gas can contain non-hydrocarbon gases such as carbon dioxide and hydrogen sulfide. Non-associated gas is directly controlled by the producer. One just turns the valves. The gas flows off the well under its own energy through the wellhead control valves and along the flow line to the treatment plant. The treatment requires the temperature of the gases to be reduced to a point depending upon the pressure in the pipeline, so that all liquid that would be exist in at pipeline temperature and pressure condense and are removed. Now we will talk about the associated gas. Associated gases is produced during crude oil production and is the gas that is associated with the crude oil. Crude oil cannot be produced without producing some of its associated gas, which comes out of solution as the pressure is reduced on the way to and on the surface. Properly designed crude oil well compilation and good reservoir management are used to minimize the production of associated gases so as to retain the maximize energy in the reservoir and thus increase unlimited crude oil recovery. Crude oil in the reservoir with minimal or no dissolved associated gas is rare, and as crude oil is often difficult to produce as there is a little energy to drive it. After production, fluid are brought to the surface. They are separated at a tank, battery, or at near the production. The production leases into hydrocarbon liquid stream, crude oil or gases, condensate, are produced water stream, brine or slightly water, and a gases stream. And now we will talk about the coal-bed methane. Coal-bed methane is generic term given to methane gases held in coal and released or produced when the water pressure within purified coal is reduced by pumping from either vertical or including to horizontal surface holes. The methane is predominantly formed during the qualification process, whereby organic matter is slowly transformed into coal by increasing temperature and pressure as the organic matter is purified deeper and deeper by additional deposit of organic and inorganic matter over a long period of geological time. We will talk about the gas phase behavior and properties. For the gas phase behavior, we can define it as a plot of pressure with temperature that determine whether the natural gas stream at given pressure and temperature consists of single gas phase or two-phase gas and liquid. The phase behavior of natural gas with the given composition is typically displayed on the phase diagram, which is shown here, where this line represents the bubble point line and here the dew point, where gas convert from double stream, which is liquid and gases, to one stream in natural gases. The right dew point, the right hand side of the curve is the dew point and divided to phase gas liquid region and the single gas phase region. The bubble point and the dew point line interest at the critical point where distraction between the gas liquid properties and between distraction between gas and liquid properties disappear. Here we can single phase, which is natural gas, here two phases liquid and gases. The natural gas phase behavior is a function of composition of gas mixture and is strongly influenced by concentration of the heavier hydrocarbon. The presence of the heavier hydrocarbon will increase the phase involved, and failure to include them in the phase calculation will unpredicted the phase involved. And now we will talk about the properties of natural gas. Natural gas is colorless, odorless, tasteless, and shapeless, and lighter than air. This is general properties. Also in this table we can see the other properties, for example relative molar mass, the carbon content, hydrogen, oxygen, and boiling point density. All these represented the properties of natural gas in general. And I would like to show that this was a very short presentation. We just give overview about natural gas. In next video we will talk about the unit that used for treatment of natural gas. Thank you a lot for attending my presentation.